We are starting section 8.5, which is now going to cover our third trig function, tangent, and we're going to learn how to graph our tangent function. This is our last section of notes for the year and our last new bit of learning material, so I hope you are excited. We are going to learn what the tangent parent graph looks like, just like we did with sine and cosine. We're going to start with a table of values, and we're going to use some values from the unit circle to help make sense of the graph. Again, the x's are going to be angle measurements in radians, and then our y value is going to be the ratio for those specific angles. I've got some negatives up here for when we want the negative side of the graph, but let's start with 0. And I put down here to the right just the ordered pairs at the axis for some of the key angles we're going to evaluate for. I also thought we could evaluate for some pi over 4s because if you remember, because of the ordered pair for pi over 4, when we find tangent and we divide the y over x, we end up getting a value of 1. And 1 is an easy number to plot on our graph, so I thought that would be a good angle to throw in as well to give us a good look at the picture. Now, we're not going to evaluate for angles like 30 degrees and 60 degrees because you might remember the tangent of those angles are radical 3 and radical 3 over 3, and that might not be easy for us to plot and visualize. So starting with 0. And if I look at the angle 0, the y value is 0 and the x value is 1. So if I do tangent 0 over 1, that equals 0. Pi over 4, we already said was going to be 1. Up at 90 degrees, the pi over 2 mark is 1 over 0. And whenever 0 is on the bottom, you might remember that that is undefined. Now we're going to talk about what an undefined means on the graph here momentarily. 3 pi over 4, that's just your 45-degree angle in quadrant 2, and it's going to give you the same value that you got for pi over 4, the 45 in quadrant 1, except for remembering tangent is negative in quadrant 2. Then as we move to pi, we do 0 over negative 1 and get 0. As we move to 5 pi over 4, we're at 45 degrees in the third quadrant. Tangent's positive in the third quadrant. We're going to have a positive 1. 3 pi over 2, negative 1 over 0. That is also undefined. Now, we're going to start to see a pattern with tangent, just like we did with sine and cosine. So while I didn't give more values to get like 7 pi over 4 and 2 pi, I think we should be able to, implement those once we get to the graph. So we'll take a look at that when we get there. We can go backwards and do some of these negative angles. Negative pi over 4, that would have been going back into the fourth quadrant, 45 degrees. So the ratio would have been a 1, but because you're in the fourth quadrant, it would have needed to be negative 1. Negative pi over 2 is the same as the 270 mark, so that was undefined. Negative 3 pi over 4 is the same as our 5 pi over 4, and we noticed that that value was a positive 1. Negative pi is the same as pi, that'll be 0. Negative 5 pi over 4, we're back in quadrant 2, the 45-degree angle there, that's a negative 1. And negative 3 pi over 2, that would be back up at 90 degrees, and that value was undefined. So as I go to plot these key points, again, we need to label our axis. And so we have been labeling our axes by pi over 2. And so let's go ahead and stick with doing that. I know we have some pi over 4s, but pi over 4 in comparison to pi over 2 is just halfway. So we should be able to still estimate that point pretty well. And then I've got 3 pi over 2 all the way to 2 pi. And then I'll label my negative angles. And then same on the y-axis. Again, the highest we need to go to is 1 and the lowest is negative 1. So you can label your axis wherever. I'm going to stretch it out just a little bit. I'm going to make 1 be that third tick mark and -1 be the third tick mark down. As long as I'm consistent and I label, I can do whatever I want. If you want to stick with each tick mark being 1 on the y-axis, then go ahead and label yours accordingly. It should not make a difference. So let's start at the 0 again, and I'm going to go ahead and plot some of my key points that we just found. So 0, 0 was an ordered pair. Pi over 4, which again is halfway to pi over 2, had a value of 1. Pi over 2 was undefined. So what have we learned? Undefineds are on graphs. So if this particular x value is supposed to be undefined, what you're going to find is a vertical asymptote. The tangent graph has asymptotes wherever there were undefined values. So that is something a little bit different. You're going to find here in a minute or two that the tangent graph looks very different than the sine and cosine graphs did, mainly because of these asymptotes that we have going through. Okay, I'm going to keep labeling my points. 3 pi over 4, that's halfway between pi over 2 and pi, and that was a -1, so I'm estimating that point. At pi, I had 0. At 5 pi over 4, so now I'm halfway between pi and 3 pi over 2, that value was 1, so I'm just estimating there. And then at 3 pi over 2, we were undefined. Now, I have 2 asymptotes now, so it's a good time to talk about what's going on in between these asymptotes. Remember the rule that asymptotes must be approached at the ends. So far left, far right, we always have to approach. Vertical asymptotes will never be crossed. So we actually have 3 points inside that create part of our tangent curve that we could draw right now. What you're going to notice as I approach this asymptote on the left, I connect my points. I do curve a little bit in there. Remember, trig functions have a little bit of curve to them. A lot of students think the tangent graph resembles the cubic function inside your vertical asymptotes. We know the cubic function actually continues to the left and right forever. There's no asymptotes for that function, but with tangent, it's just a similar shape to refer to, and they are bound by asymptotes on the left and right. This right here is one cycle pattern of the tangent curve. And remember, once we know that cycle, what that pattern looks like, we can reciprocate it to the left, to the right, forever in all directions. Hopefully you remember the key word we use for trig functions when we talk about the length of that cycle or pattern. So remember, that is known as the period. And what you may notice about the length of our cycle pattern, what the length of our period is from pi over 2 to 3 pi over 2, that is a distance of pi units. Another difference from the sine and cosine graphs, because if you recall, their period was 2 pi. It took from 0 to 2 pi for a pattern to be created for the sine and cosine. So again, we start to see some differences with the tangent curve. Let's continue to the negative, and you can either use the ordered pairs or you can maybe imply the pattern to get more points. So as we went to negative pi over 4, so that's halfway between 0 and negative pi over 2, that value was -1. And then at negative pi over 2, we had that undefined. We had another vertical asymptote. So again, I see 2 vertical asymptotes. In between, I have 3 key points, and I can go ahead and draw my tangent curve inside of there. So while the sine and cosine graphs needed 5 key points in order to graph their period, notice we only need 2 asymptotes and 3 key points in order to get our tangent graph going. You can keep using these points to get more, or you can apply the pattern. And so what I notice about the pattern is, if there was an asymptote at negative pi over 2, I should see in pi away, which pi is 2 tick marks away, there should be another vertical asymptote. And then I know I need 3 key points in between my vertical asymptotes. And the one key point is on the x-axis, and that's at the halfway mark. And then because my tangent curve is going to rise from left to right, if I'm halfway at the pi over 4 to the right of that x-intercept, I know I should be up at +1. And if I'm halfway at the pi over 4 to the left of that x-intercept, then I know I should be down at -1. And then I can draw my tangent curve. I typically like to at least see 3 periods of your tangent curve. If you want to keep going and fill the graph, again, it's just a pattern. You can keep applying it if you wish. So this is your tangent parent. All right, so let's talk about the range, because I think the range is easiest for most students to see. These graphs are going down forever and up forever. Therefore, our range is all reals. So I'll use our fancy all real symbol. The domain is going to be a little trickier, and we are actually not going to give domain in Algebra 2 quite yet. We'll save that for pre-calculus. But what we can say about the domain is that we have to restrict asymptotes. So just in general, what you could say about the domain is you know that it's all reals except the asymptotes. And we can't really write that in interval notation, because we would just have infinitely many intervals. And there's some different symbols and math that kind of goes into this setup, which is why we'll save it for a time when we're actually in class and can talk about it a little bit better. And so pre-calculus next year will be a good time to introduce this. What I might ask you on quizzes and on homework is, instead of giving me the domain, I might ask you to tell me some values that are not in your domain. And in that case, you would just list some of the vertical asymptote values. For example, in this graph, pi over 2 is not in our domain because it was an asymptote. 3 pi over 2 is not in our domain. Negative pi over 2, so on and so forth. So just to prep you for that down the road. All right, let's talk a little bit more generically and kind of fill in some of these notes at the bottom here. The next problem asks you, what is the period of your tangent graph? And we did answer that already. We know that our period is pi. Some important characteristics, I would say, knowing that you need 2 asymptotes and 3 points. I'm going to abbreviate in between. I just abbreviated between there. So we need 2 asymptotes and 3 points in between to create one period. Next, I would say one key point is the midpoint between the asymptotes. Now the other 2 key points, those points are halfway between the x-intercept we just found, and maybe we should say that that one key point at the midpoint is an x-intercept. That's your 0 point. And then the other 2 key points are halfway between the x-intercept and each asymptote at 1 and -1. So halfway between the x-intercept and the asymptote at 1. Now the 1, remember, is on the right. And -1 is on the left. that gives us the tangent look of rising from left to right, which is very important. All right, so this should help us know our parent graph. Now, because you don't want to have to recreate a table every time for your parent, what I try to get most students to remember is that your first asymptote is always at pi over 2. Right? And if you can draw that one asymptote in and you understand the patterns we just talked about down here in the box, you should be able to recreate the entire graph. Because remember, the next asymptote is going to be a period away, which again is just pi units away. And the way we have things labeled, that should be 2 tick marks away from the first one. So you can kind of move those 2 tick marks and then you could draw your second asymptote. You could go 2 tick marks the other direction and draw another asymptote. And once those asymptotes are set up, then you can get the points inside and draw your curve. So again, that's how I recommend maybe memorizing how you create the parent for tangent. Now we have to talk about the transformations that can happen. We know that we can move this parent left, right. We know we could have a stretch vertically. So maybe we stretch these key points, either stretch up, or if we compress, we might shrink them down. We could have a reflection that happens. And lastly, we could maybe have a vertical shift where we move the entire graph up and down. Most of these transformations are going to be pretty easy to do based off of your parent. However, if you thought when I said moving left and right, that one's going to be tricky because you're going to take all these asymptotes where we have them set up right now, and they're going to have to shift left and right. That could make a big ugly mess on your paper or on your iPad in this case. And we want to avoid that from grading purposes and for your own sake. So when I teach students how to graph with transformations for the tangent curve, I always tell them, start again at this pi over 2 as your asymptote, and then apply your left-right shift before you draw anything. So essentially, you're probably not going to draw the parent graph. You're going to always draw the parent graph with any left-right shifts as your first graph. Now, if there are no left-right shifts, then yes, you will create this parent graph for yourself, and then the other shifts can happen from there. I know that's a little tricky, so we're obviously going to do a practice so that you see what I mean, but just from the transformation perspective, I just want to write that down in here. So we're always going to graph horizontal shifts. And I'm going to remind you again that we call horizontal shifts the phase shift. With the parent. Then you can do any vertical stretches or shrinks. That's again, that A value. We did call it an amplitude with sine and cosine. In tangent graphs, it's not called the amplitude because it's not really measuring a distance anymore. It really truly is more like a vertical stretch shrink. So we get away from using the verbiage amplitude with tangent graphs. Then we can do any reflections. Remember, those are your negatives. And then lastly, we will do any vertical shifts, the up, down. And remember that in the case of our tangent and trig setups is our D value. All right, so again, this is the basics. I'm going to stop the video here for time purposes in case you need a break, and then I'm going to come back and I will make a video of this example so we can practice one together.